Hi, so now we are going to be talking about future calls. Future methods are another way of performing asynchronous processing on the Salesforce platform. So, future methods or future calls, as they are referred to generally on the Salesforce platform, are asynchronous jobs running in a separate thread when resources become available. Uh, the easiest way to identify a future method is through using an at the future annotation that you see right here. So any method annotated with an at future notation is a future method and basically runs in a completely different execution context uh, from the one that it is being called from. Okay. One of the special things about a future method is that it works and it generally operates only with some primitive types. And we'll talk more about that in a bit during our demo. But primitive types are basically the basic older primitive types that we have talked about in our session one of the Apex Hours Dev program. For example, some of the sample primitive types that we can think about is strings, number, integers, or decimals, or IDs. Those could be primitive types. Now, future methods are generally applicable or generally used when you really want to perform um, call outs or make calls to external web services, or you really want to execute complex calculations which require time of their own, or they can be used to resolve a mixed DML operation error. So mixed DML operation error is a very special error that occurs when operations on setup and non-setup type of objects in Salesforce are performed or are attempted to be performed in a single execution context. So basically, Salesforce defines objects into two basic categories: setup objects and non-setup objects. So any transactional objects that you have, which are more CRM transaction driven, like accounts, leads, contacts, opportunities, cases, or any associated objects are typically called as non-setup objects. But however, objects which have more to do with the setup or the configuration or are more like the metadata in some or the other way. For example, users or profiles or groups, which policies are accessed set of objects. Okay. One type of object updated or other in the other execution context. And since future methods operate in a different execution context, this kind of really comes in handy. So with that, let's quickly jump over to the demo and see how you can simply write future calls. Uh, so for that, I'm going to switch over to my Salesforce instance. Um, and I'm going to quickly open the dev console. So I'm going to click the gear icon and open the dev console. So sorry for that. So I'm going to close all the tabs. And then while I'm waiting on the content to be loaded, okay. So I'm going to say and create a new Apex class. Future methods are just written like a normal regular methods within an Apex class, right? The only thing is that they operate or behave in a very special way. So I'm going to go and create an Apex class. I'm going to call this class as future demo. Okay, which we'll create a class with the name future demo. Now, in the interest of time, I'm just going to copy my demo code, which I already have prepared over here, and then we'll talk about that in the detail. So I know there's a ton of code, which is, so let me just save that and just make sure that everything is fine. I'm going to open the problems tab just to make sure that there are no errors. Okay. All right. So just to give you a perspective, future methods are basically within within a regular class, right? And future methods have a very specific type of anatomy or a specific skeleton. Future methods can generally be public or uh, global. However, the key trait here is future methods are always static and do not return anything, which means you cannot return anything from a future method. And that's purely because future methods operate in a different context or operate on a different thread as compared to other methods, regular methods, right? So this is so rest of the way of defining the method remains the same. So here I have a very simple future method defined, and it's annotated with the add feature annotation. So let's see how you can really invoking a future method. I'm simply invoking or a future method from the invoke future call, which is a regular instance method of the future demo class. So in order for me to invoke the future method call, I could directly do it from the class itself, or in this case, I'm just because I've just written a, a wrapper method. I'm just going to call this invoke future call method, and this in turn will invoke the future method call. So let's quickly go and see how you can do that. So in order to do that, I'm going to just do it the way I call a regular instance method. So I'm going to create a new instance of the future demo method, which is here. And then I'm going to, because invoke future call is an instance method, I'm going to use the instance to call that method, right? And now let's see how this operates. So I'm going to do scene execute, and this will result in, so which future methods sometimes execute really fast, although they execute on a different thread. So let's see if it has executed. So if you really see the statement within the future, so the invoke future call in turn called the future method one, which called as method, and the statement got printed, which you can see in the debug log right here. Now let's go and check out some other features of a future call, right? And for this, what I'm going to do is I have a couple of other future methods also. One of the things about future methods is that, it doesn't really obey the order in which it is called. Okay, so it looks like we've got some errors. So let's just fix that. The errors are only because the actual method definitions were kind of commented out and I was trying to make a call. So Apex was not really able to recognize that these future methods actually existed as part of the class. So I'm going to do a quick save and see the errors are all gone. Okay, wonderful. So now what we're going to do is we're going to do the same thing, but what we're really trying to do is we're trying to confirm that, so the platform says that future methods do not execute in the or do not obey the order in which they are called, and they could fire randomly because they completely operate in a different execution context, and that depends on the availability of resources. So it is not, if I would call a regular method in the same fashion, they would all execute in the order in which they are actually invoked. But in this case, because it's a future method, we cannot really guarantee the order in which they are invoked. So this is an important aspect to keep in mind when you're really using future methods. So in case if you're using, uh, you're trying to use future methods to perform operations which are sequential in nature, and these operations are being performed from different future methods, then future method may not be the right solution or the right fit in that case. Okay, so let's quickly go to the execute anonymous window and invoke the future call. And now if you see, there should be ideally three future executions. So what I'm currently going to do is go to the logs tab and see that there are three future handlers which got executed. Now let's go and see one by one which of the feature handlers. So if we see, there was one which got executed first, and then second and third. So I'm going to open up the first one right here. So and if I check if there's a debug, so if you see, the third method got executed first, right? And then I open up the second one, and in this case, the second method got executed. If I open the first one, this should have future method one. So irrespective of the order, the order in which they got called was completely different. And this could really vary every time you call. Hence, there is no guarantee, or future methods do not respect the order or the sequence of invocation. This is a very important aspect to keep in mind. Another very peculiar trait about future methods is that future methods only operate with primitive types, which means that if I try to pass a string right here, right, and let's alter the definition. Future method, I'm going to pass a primitive value, or basically a collection of primitive type, which is string in this case. And I'm going to say, because this is a string, I'm going to say list of string, and I'm going to name the input param as input param, and then I'm going to comment this particular method right here. And let me quickly see and do a save and see if that works, and that gets rid of all the errors, right? I'm going to close all the other tabs right here. Sorry about that. Just do a quick save, just making sure everything is spick and span. And now I'm going to invoke the future method. In this case, you see that I am allowed to pass a primitive type as an input parameter to a future method, and it works flawlessly. So we just execute it once just to confirm that everything, we're not receiving any runtime errors. So it executed, and because I passed a string parameter, the string parameter actually got passed over and got printed over to this future method. However, now let's quickly check out the behavior in case when we are really trying to pass non-primitive types. And in this case, I'm trying to pass count record, which is an S object type, essentially a non-primitive type, right? So I'm going to just say count record, print, and then I'm going to comment this and quickly change the type of uh, what all I did was just change the type so that the type that the method accepts versus the type that's being passed is the same. And now, even before when I do a save, I think we already got an error which clearly says that future methods do not support parameter type of account, which kind of informs our statement that future methods do not operate uh, with non-primitive types. Like, in the first case where we passed a string, it just worked flawlessly and it was able to understand. um, However, with non-primitive types, that's not the case. And the reason why future methods do not really support non-primitive types, or complex types as they're called, is because of the fact that future method uh, operates in a different execution context or in a different thread, and hence uh, the state of the state of the non-primitive types could change from the time it is actually passed and the time the future method actually executes. And this could essentially be a challenge. um, and the reason is because, if you just circle back to my previous introduction to Apex uh, topic day 2, these complex types are typically passed by reference, which means the state may change, and that is the reason why these things or complex types are not really supported by future methods. So that was so I'm going to just change this back and comment this and remove the input parameter right here. Remove it from the actual method and just comment this out. Just do a save, and everything should be fine. So basically, this was a very quick, simple demo on understanding how future methods work. One specific thing about future methods is, in case you want to make future methods do allow performing web service calls or making REST or SOAP calls to external systems. And if you want to do that, um, you just need to add an attribute to the annotation which says call out true, and just do a save. Okay, looks like there is an error. So I think I misspelled it. So I'm just going to say call out equal to true. And yep, that's it. So basically, any method marked with as call out equal to true, only those future methods will allow making callouts or HTTP calls, REST or SOAP in the form using REST or SOAP to external systems. So this is an important aspect. All right, with that, I'm going to circle back to my slide deck and look at some key considerations for implementing future methods. I think some of them have been already discussed, but I'll just quickly go over them. Future methods need to be static and do not return anything other than void. So the return type is always void for future methods. Uh, they do not obey the order of execution, which means that if your functionality really needs or has the need for sequential processing, then future methods may not be the right tool to use. Um, like we demonstrated, they only use primitive types, and complex types cannot be really used. And another key thing to note is you cannot invoke a future method from another future method. So those are just some of the key considerations of using future methods. Now with that, we'll cover another important artifact that the platform Salesforce Customer 360 platform provides for asynchronous processing in Apex, and that's called as Queueable Apex. So Queueable Apex is a form of or provides the ability to perform asynchronous processing. Um, However, the beauty about Queueable Apex is that it you know it respects the order of invocation, which means that if you have a SQL requirement for sequential processing, then Queueable Apex is your friend here. um, Sorry about the misprint, but anyways, in order to implement Queueable Apex, all you have to do is implement the Queueable interface, which comes from the system class or is a part of the system class. So system.queueable interface is what you will implement. The best part about Queueable is that it supports primitive and non-primitive types as well. Generally is the best fit when requirements require a job chaining kind of a thing. So a simple blueprint of a Queueable Apex class is you have the class keyword and the class name, which with the implements keyword, and that is followed by the Queueable interface. And because it is an interface, it mandates a method. So just like your batch jobs, you have execute method, which so you only have to implement your execute method and write the code. In order to invoke a Queueable job, all you have to do is instantiate the class that implements the queueable interface and then make a call to the system.enqueue job. So this is a standard function that is available as a part of the Apex um, classes or as a part of the Salesforce Customer 360 platform, and then pass the instance. This kind of once this is done, this enqueues or basically queues up the job or the process in the Apex jobs queue, and then gives you back the ID, which means that if this is, you basically do not know when the job is going to execute and finish, and then you can really use this job ID to query the async Apex job object to understand the status of the queued job, whether it is started, whether it is progress, or it is completed or failed, or all the terminal states that apply to the regular batch jobs also apply over here. Um, one very notable thing about Queueable Apex, as compared to Batch Apex, is that Queueable Apex doesn't really operate in batches, which means that total number of batches and the batches processed or failed will always be zero. Now let's quickly jump over to the demo and see how we can write queuable calls in Apex. So I'm going to quickly switch back to my develop console, and we don't need this future demo anymore, so I'm just going to quickly close this off and really so we're creating a new Apex class called Queueable demo, and in the interest of time I'm just going to quickly copy paste the code that I have here. So what I've really written is I have a queuable demo class which implements system.queuable, the interface, and then because it's an interface, I'm mandated as a subscriber or somebody who's as an implementer of the class implementing the system.queuable interface to write the definition for the execute method. Uh, so I have written a very basic set of statements. I've written a printing session.debug, which kind of prints this to the debug log, and then because I just wanted to showcase that queuable my uh, queuable job kind of supports non-primitive types as well. So I just quickly made a simple query on an account object, and I'm just printing those out, that list over here. Now, in order to make a call to a queuable job, what I'm going to do is quickly go to the anonymous window. I'm going to copy this class name, instantiate the queuable class, and here we'll have to make a small change, and I'm going to say system.enqueue job, and I'm going to pass the instance of a class which is actually the queuable demo class, right, in this case. And this is going to return a job ID. I can, if I don't want to hold it, I can choose not to, but just to showcase that it returns a job ID. I'm going to, and then we will try to print the job ID as well so that we know. And I'm going to now say, first of all, let me just copy this. Just make sure that there is no issue, and I'm going to just save my queuable class before I go ahead and run it. So I'm going to go back, and now I'm going to say execute, and looks like everything went well, and the job was enqueued in the queue. So let's see if I did get back a response. So the job has been executed, right? Sorry, yeah, the job has been executed, and that's the reason why the data that we queried, we are actually able to see all of those records over here. Now let's go back and actually see if the job is executed. All you have to do is you have to go to the setup window, go to the, once you're in the setup window, go to, and in the quick find, just type in jobs. That will bring up these options, and then look for Apex jobs. Okay. All right. So happened. Let me quickly refresh the page, go back and say jobs, and then do Apex jobs. Yeah, so if you see that, there was a big list of there was not a very big list of jobs, but because we executed future demos or future methods, they are also showcased under Apex jobs. And the queueable demo, the queueable class that we executed, also got completed successfully. And all of these, basically all asynchronous jobs, show up under the Apex jobs section. So it states that this is completed. And if you really see, the batches processed are zero, because technically there is no batch creation or chunking in the form of batches that is happening for queueable or for future jobs. So let's just see if we can go and search for logs, and there is a queueable handler. But yeah, like I said, the job is already executed. And so this is, let me switch back to my, so this is a simple demonstration of how you can write queueable calls in Apex and really ensure that even while performing asynchronous processing, the order of invocation is really respected. With that, I we've discussed quite a bit of techniques over here of being able to process uh, asynchronously using Apex. However, it's important to understand the difference of when each of them is applicable, and when each of these asynchronous processing artifacts offered by the Salesforce Customer 360 platform are the right tool for the job. So let's just look at a simple comparison matrix over here. So here, this side of the table right here identifies the need, and these are all the four artifacts that are available in Apex to perform asynchronous processing. So let's just quickly let me give you a quick rundown. So in case you want to really process large volumes of data asynchronously, then of course Batch Apex is your choice. It's your tool of choice, because you know that Batch Apex is capable of processing 50 million records. However, if you want to execute logic based on a specific time period, or wanted to base at specific intervals, then Scheduled Apex is your tool of choice, because it allows you to provide a cron string and really configure that and use that. If you really want to perform web service calls, you can do that with all these three. However, based on the nature of processing within the web service call, if you want to do multiple web service calls, when you want to do high volume processing, then you might do it in conjunction with a batch Apex. However, if you want to just do, sorry about that, if you want to do a very quick call from the UI user interface, uh, future method might be your tool of choice. However, you want to run it at regular intervals, or maybe run a nightly or a fortnightly or a monthly job, then probably Scheduled Apex is your tool of choice. Um, Generally, none of these you know uh, artifacts respect sequential processing. Hence, if you want to have a requirement for something like chaining, and you want to respect the order of invocation, then unfortunately, Queueable Apex is your only tool of choice over here. Last but not the least, if you want to process complex types and are not really happy with being able to process only non-primitive types, then you have the order, or you have the luxury of choosing from Batch Apex, Scheduled Apex, and Queueable Apex. Future methods do not support complex types, and they only support non-primitive types. So that's a quick rundown of which async artifact to use when. Thank you.